This video is all about proving the derivative of e to the power x with respect to x is equal to x. Now, we're going to prove this using the limit definition of derivative, which is the first principle, using the first principle of derivative. Now, if you have the derivative of f of x with respect to x, this is the same thing as the limit of f of x plus delta x minus f of x divided by delta x when delta x tends towards 0. So now using this, now from this expression, our f of x is equal to e to the power x. Then f of x plus delta x is equal to e raised to power x plus delta x. Now substituting this into the equation, you now have delta, you now have d e to the power x all over x is equal to e to the power x plus delta x minus e to the power x all over delta x limits when delta x tends towards 0. Now with this, we can now see, according to the law of logarithm, let me just write it here. You have d all over dx, which is e, is the same thing as saying you have the limit of delta x tending to 0 of e to the power x plus delta x minus e to the power x all over delta x. According to the law of indices, if you have e to the power m plus n, this is the same thing as saying e to the power m times e to the power n. So this is the same. So applying that rule here, we now have the limit when delta x tends to 0, e to power x times e to power delta x minus e to power x all over delta x. Now, e to power x, e raised to power x is common. Now we factor it out. We now have the limit of delta x tending to 0 when e to power x bracket open times e to power delta x minus 1 all over delta x. Because now if you factor this out, if you remove this, you have this left. If you remove this from here, you have 1 left, minus 1. So that is it. Now, the way this is, let's now do kind of change of, let's do a change of variable. Now, let me assume that t, now let me say let t be equal to e to power delta x, then minus 1. Now, moving this minus 1 to this other side, you have t plus 1 equal to e raised to power delta x. Now, taking the log of, natural log of both sides, you have ln 1 plus t equal to ln e to power delta x. So, and again, this is equal to, according to the law of logarithm, if you have ln a to power b is it's same thing as b ln a. So rewriting this in this form, you have delta x ln e, and ln e is equal to 1, so this is the same thing as delta x. So from here we have delta x to be ln 1 plus t, while t is equal to e to power delta x minus 1. So substituting, let me call this equation 1 and call this equation 2 and 3. Let me just, now substituting equation 1, equation 2 and 3 into equation 1, you will now have, this to be equal to e, the limit. Now if you look at this now, when delta x tends to 0, t, because delta x tends to 0, here will be 0, e raised to power 0, anything raised to power 0 is 1, so 1 minus 1 is 0, so t also tends to 0. So we want to change it now. So now let's say this is e, so t will tend to 0. So we want to change the variable. So now when delta x tends to 0, t tends to 0. Then here e to the power delta x minus 1 is t. So we replace that with t, divide by dx, which is ln 1 plus t. So let me write it properly. Sorry, let me just clean this and write it properly. It was not well arranged. So it's just the limit of t tending to 0 when e to power x times t divided by ln 1 plus t. Now, if you look at this expression, now the limit is t tends to 0. So this one does not relate with this. So it's a different variable. So we now have to bring it out. We now have x limit of t tending to 0 when you have t all over ln 1 plus t. So this is what we are up against. So now this is it now. So this will now be, you have e to the power x times the limit. Okay, now the limit when t tends to 0, you have t all over ln 1 plus t. Now the way this is, we can now say we multiply the up and the down with 1 all over t. If we multiply the up with 1 all over t, this one will cancel out. The numerator here now will be 1. So we now have e to power x limit when t tends to 0. Then you have 1 all over. This will be, this times this will come to this side, you now have 1 all over t times ln 1 plus t. So that is it. So now, having gotten this, we can now look at the limits again. Now you have e to the power x limits of t tending to 0, 1 all over ln 1 plus t raised to the power 1 all over t. So from here, I use a law of logarithm. If you have a ln b, it's the same thing as saying ln b to the power a. So I will use this expression here now to result. That was what result to this. Now, if you look at this expression here, this small parts here, it looks like the definition of e, which is the limits when, let me say, when b tends to infinity, you have 1 plus 1 all over b raised to power b. Now, if you look at this, let's now write it in this form. You have t to be equal to 1 all over b. So when b tends to infinity, t tends to 0. Now, if you multiply both sides with b, you have bt equal to 1. Now, if you divide both sides by t, you have b equal to 1 all over t. So let me just explain it further down. Multiplying this equation, this one now, both sides by b, you have bt equal to 1. So divide both sides by t. T will cancel. You have now b equal to 1 all over t. Now we are going to replace b. Wherever we see b, we put 1 all over t. Wherever we see t, wherever we see 1 all over b, we put t. So now look at this now. It's expressed as e is equal to the limit of b tending to infinity when 1 plus 1 all over b raised to power b is equal to the same as the limit when when b tends to infinity, t tends to 0. When t tends to 0, the limit when t tends to 0 is the same thing as say 1 plus 1 all over b is t. So replace here, then b is 1 all over t, so 1 all over t. Now, if you put this, if you look at this, it looks the same exactly as this. So now, looking at this expression up here, which states that the derivative of e to the power x is equal to e to the power x. Now, this limit, now it does not have any effect with this. So now what we do, we bring this limit should go in here. So now we'll now say e to the power x 1 all over times 1 all over ln into limit when t tends to 0, then of 1 plus t into 1 raised to power 1 over t. Now, if you look at this expression here, it's the same thing as e. So now let's replace this with e here. You now have e raised to power x times 1 all over ln e. So now it now means that the derivative of e to the power x is equal to e to the power x 1 all over ln e. This is the same thing as saying the result is e, because ln e is equal to 1, so e raised to power x times 1 all over 1 is equal to e raised to power x. So that means the derivative of e raised to power x is equal to e raised to power x. So this is the final answer. Please, let's say if you have a different base other than e, let's say you have a problem like this. You have, let's say you should find the derivative of a raised to power x. Now, let's say you have this kind of expression. Now, using the first principle also, you know that using the first principle where you have the derivative of a function with respect to x is the same thing as the limit of a function x plus delta x minus f of x divided by delta x. Now, we now have something like this. I have to be very fast here now. So now, assuming now we're looking for this. So that means our f of x is equal to a raised to power x, and f of x plus delta x is equal to a raised to power x plus delta x. Now, substituting this expression into this equation, we now have the derivative of a raised to power x is equal to a raised to power x plus delta x divided by minus a raised to power x divided by delta x, the limit when delta x tends towards 0. Now, using the law of Lagrange, where you have law of indices, sorry, when you have a raised to power m plus n is the same thing as a raised to power m times a raised to power n. So applying that rule here, you have the limit when delta x tends to 0. You now have a raised to power, a raised to power x times a raised to power delta x minus a raised to power x all over delta x. When you check the whole of this, you have a common factor here. So this will now be the limits. Okay, can enter here. Put it here. The limit of delta x tending to 0. Now this is common. Factor it out. You have a raised to power x. Use a raised to power x to divide this. What you're left with is a raised to power delta x. A raised to power x divided by a raised to power x, you have minus 1 all over delta x. Now let's do change of variable. Now do change of variable. So now let me just say derivative of delta x, delta a raised to power x, not delta x, sorry. Derivative of a raised to power x will now be the limit when delta x tends to 0, a raised to power x into bracket open a raised to power delta x minus 1, minus 1 all over delta x. Now let me demarcate here. Now assuming b is equal to a raised to power delta x plus 1 minus 1, sorry. Now moving this minus 1 to this side, you have b plus 1 equal to a raised to power delta x. Taking the logarithm, the natural log of both sides, you have ln b plus 1 is equal to ln a raised to power delta x. So now this expression is the same thing as saying ln a raised to power b is equal to b ln a. So applying that rule here, now you now have ln b plus 1 is equal to delta x ln a. So now dividing all through by ln a, you have delta x is equal to ln b plus 1 divided by ln a. Now we'll have delta x, sorry, we have delta x, and we also have this expression. So changing variables, we want to change variables from delta x to b. Now we are going to have this to be equal to the limits of, now if you look at this here now up here, from here you can see that when delta x tends to 0, b tends to what? Now if delta x tends to 0 here, anything raised to 0 is 1, 1 minus 1 is 0, so b will tends towards 0. So I'm changing the variable from delta x to b. So now b, as delta x tends to 0, b tends towards 0. And then now you have a raised to power x. Then this expression here is equal to b. So replace it with b divided by delta x is the same thing as this. So this is ln b plus 1 divided by ln a. Now this is the same thing as saying a raised to power x times b times ln a divided by ln b plus 1. So let me just erase this to explain how we got that. Now you know a raised to power x, so the limit is supposed to still be there, limits in 0. So now lx over lx times b divided by ln b plus 1 all over ln a. So this is the same thing as a raised to power x times b divided by ln b plus 1 all over ln a. So this can still be a raised to power x times b. Then if you want to change this to times, this ln a will now come up divided by, now you now reverse this for you to change this to times, from this division to times, so you have b plus 1. Now that is how we got this. So that means the limit when b tends to 0 a raised to power x times b ln a divided by ln b plus 1. Now multiplying both sides by 1 all over b, you now this b will cancel out this. You have, and this a raised to power x is a different variable to this b, so to go out, so it will be a raised to power x limits of b tending to 0 ln a all over ln b plus 1 times 1 all over b. So that is what we have now. So the derivative of a raised to power x will now be equal to a raised to power x times the limit of when b tends to 0 ln a all over ln 1 plus b raised to power 1 all over b. Applying this law of logarithm where you have 1 all over b, or where you have b ln a is same thing as ln a raised to power b. So that is what we applied here. Then now you have a raised to power x ln b tends to 0 no limit when b tends to 0 ln a divided by ln 1 plus b raised to power 1 over b. Now this is b, this is a, so this limit does not affect this. So it only does not affect this ln, it only affects this one here. So we now can rewrite that to be a raised to power x divided by ln a all over ln limit of b tending to 0 1 plus b raised to power 1 all over b. So if you look at this, it's the same thing as e. It's the same as e. So we can now write this. This is the same thing as e. The definition of e is equal to the limit when b tends to 0 of 1 plus b raised to power 1 all over b. This is e. So replacing this value with e, you now have a raised to power x times ln a divided by ln e. So from here, the derivative of a raised to power x will now be equal to a raised to power x ln a all over ln e. So and ln e is equal to 1. So the final answer is a raised to power x ln a. So that is the final answer. Thank you for watching. Please subscribe to my channel, like, comment, and share the video. Thank you.